Let's depict the Lewis diagram of CS2, commonly known as carbon disulfide. Just follow these simple steps to accurately draw the Lewis structure of CS2. In the first step, we'll draw a rough diagram of the structure. In the second step, we'll illustrate the chemical bonds between the atoms. In the third step, we'll determine how many lone pairs each atom will have and distribute them accordingly. The fourth step involves ensuring that the octet rule is satisfied for all the atoms. Finally, in the fifth step, we'll calculate the formal charges for each atom and verify whether the final structure is stable. To draw a rough diagram of CS2, we first calculate the total number of valence electrons and then identify the central atom. The total number of valence electrons in CS2 can be determined by summing the valence electrons of each atom in the molecule. Carbon, a group 14 element, has 4 valence electrons, while sulfur, a group 16 element, has 6 valence electrons. In CS2, there is 1 carbon atom and 2 sulfur atoms. Therefore, the total number of valence electrons is calculated as 4 plus 6 multiplied by 2, which simplifies to 4 plus 12, which equals 16. Thus, CS2 has a total of 16 valence electrons. When determining the central atom for CS2, prioritize placing the element with the lower electronegativity at the center. The electronegativity of carbon is 2.55, and the electronegativity of sulfur is 2.58. Since carbon has a lower electronegativity value than sulfur, carbon should be chosen as the central atom. Therefore, in the rough diagram of CS2, place the carbon atom at the center, with 2 sulfur atoms arranged outside. A single chemical bond is represented by 2 electrons. Therefore, we will place 2 electrons between the carbon and sulfur atoms. In this way, we have used 4 electrons to represent 2 chemical bonds. As discussed earlier, we had a total of 16 valence electrons. After using 4 electrons, we are left with 12 unutilized electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. Each lone pair contains 2 electrons. As we discussed earlier, there are 12 unutilized electrons. From these 12 electrons, 6 lone pairs can be formed and marked on the structure. It's important to note that carbon, which belongs to period 2 of the periodic table, cannot hold more than 8 electrons in its outer shell. In contrast, sulfur, a period 3 element, can accommodate more than 8 electrons in its valence shell. Another important point to remember is to always begin marking lone pairs on the outer atoms first, followed by the central atom. In CS2, each of the 2 outer sulfur atoms is assigned 3 lone pairs, while the central carbon atom does not receive any lone pairs, as there are only 6 lone pairs to distribute in the structure. The current structure of CS2 indicates that each outer sulfur atom satisfies the octet rule, but the central carbon atom does not. Therefore, we will now work on completing the octet for the central carbon atom. It's important to remember that carbon is a period 2 element and cannot hold more than 8 electrons in its outer shell. The carbon atom already has 4 valence electrons and requires 4 more to complete its octet. Therefore, we will convert 1 lone pair from each sulfur atom and transfer them to the carbon atom to form chemical bonds. It can now be observed that the central atom, carbon, and the 2 outer sulfur atoms all satisfy the octet rule. Therefore, the octet rule is met. Next, we'll calculate the formal charges of the atoms to evaluate the stability of the structure. This is the formula we can use to calculate formal charges for the CS2 Lewis structure. formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and allocate the values to determine the formal charges for each corresponding atom. For carbon atom, valence electrons equals 4, non-bonding electrons equals 0, and bonding electrons equals 8. So, the formal charge will be equals 4 minus, 0 minus, half multiplied by 8, which equals 0. For each sulfur atom, valence electrons equals 6, non-bonding electrons equals 4, and bonding electrons equals 4. So, the formal charge will be equals 6 minus 4 minus half multiplied by 4, which equals also 0. The formal charges on the carbon and each sulfur atom are indicated, and it is evident that all atoms have a formal charge of 0. Therefore, this structure can be considered the final stable Lewis structure of CS2. To represent a bonding pair, we draw a single line between the atoms. In this structure, there are 2 pairs of electrons between carbon and each sulfur atom, so we draw 2 lines between them to represent a double bond. Thus, the final Lewis structure of CS2 has a central carbon atom forming double bonds with 2 outer sulfur atoms. This is how the Lewis structure of CS2 is drawn. If this explanation helped, tap the like button, share it with your friends, and subscribe to stay tuned.